We're going to cover lesson 8 today, which is basically the first part of our control structures lecture. So what we're going to see here in a little bit is the different methodologies that we can use for organizing our code, and the way that we can control the way that the code flows. So up to this point, you've basically been just doing procedural programming, right? One statement after another, after another, after another. So there will come a time when you want to perhaps repeat a particular block of code over and over again, and that's where repetition structures come in. Or you might want to make a decision, have a decision in your program where we evaluate the current state of a variable, and if it's one setting or one state of a particular variable, we might go one direction with our code, and if it's a different state, go a different direction with our code. And so those are called decision structures. So 2 lessons that, and all of that, it just falls under this category of control of flow of control. So let's actually just jump down here to the introduction, and you'll see what I'm talking about. So the actions that a program takes are expressed in statements. So that's what we write out. You know, every time I say, well, that's a complete statement, you want to end it with a semicolon. That's essentially what you've been writing out so far. Some of the common actions then are declaring or initializing our variables. So you've done that. Assigning values to those variables, you have done that. You have called methods because you're using the write line method and you've used the read line method. You haven't created any custom methods yet. And since we're working in a object-oriented environment, you really won't encounter functions, but what you learn about methods will pretty much apply to functions. And then you can see the last 2 we haven't done yet. So there's the looping through a collection. So an array, you might recall, is a data structure where you can have multiple values. So that's what we call a collection then of data, collection of values. We've talked about we could have lists. There's also dictionaries and tree structures. There's a lot of these structures out there where we can have one name that's used to represent a large collection of data. And so in order to process that data, you need to go through, taking the array as an example, you know, one element at a time. You might want to go through and evaluate each of the values or modify those values somehow. So we use looping to do that with. And then branching is where we actually make a decision, or we put in a block of code, or I should say actually a statement that is an expression that needs to be evaluated. For instance, is X greater than Y would be a simple example. So the expression is X greater than Y? That needs to be evaluated, and depending on the values of X and Y, one will be probably greater than the other. They could be equal to. But anyway, we want to evaluate that expression, and depending on how the evaluation turns out, it'll either be true or false, and depending on that result, whether it's true or false, then the flow of our code will make a different path depending on the results there. So the order then in which these statements are executed in the program is called the flow of control. Now, that's not to be confused with flow control, which we use in networking, which is how we deal with how the bits flow across the network. Another term that you could use there too would be flow of execution. So flow of control or flow of execution, either of those basically is what we're referring to, what we're talking about here in this lecture. So the flow of control is going to vary as your needs of your program varies. So it depends on how the program reacts to various inputs and the values that it's receiving at runtime. The emphasis on explicit control of flow distinguishes an imperative programming language from a declarative programming language. So back lesson 2, or I think it was, or maybe lesson 1 even, we talked about the different styles, paradigms that we call them, of programming. And we're saying that, you know, we use procedural programming, but there's another term for that too, which is imperative programming as opposed to declarative programming. So declarative programming is like HTML, which you probably haven't experienced yet, but in HTML, we're basically giving a text document and you need to go in and you need to mark up what the components of that document are, like where's the headings, where's the paragraphs, where's the bulleted list, things of that nature. So you use these little things called tags to encapsulate the text. When you're encapsulating the text, you're just identifying with those tags that this is a heading level 1 perhaps, or heading level 2, or this is a paragraph. So those are declarative. We're not actually writing code that is going to be processed and generate numeric results from it, is kind of the simplest way to say that. It's more just identifying the components of a program as opposed to creating functional, meaning you can actually add and subtract and divide, do mathematical operations and things of that nature. So that falls under the category of imperative programming. So all they're saying is that flow of control is what is part of, or what would be a property of, really, of imperative programming. So also there is this theorem out there. In the next paragraph, you can see there's a hyperlink. This takes you to a wiki page that defines that theorem. But structured program theorem basically defines that you can solve any computer program using one of the 3 structures that you see in the graphic there. So the sequence structure, that's essentially the procedural that we've been doing. So line by line, statement by statement, it's being processed. Then in the middle there, you can see is the selection structure. So that's going to be what we call the decision structure, where we evaluate variables or values within the program to form an expression, again, x greater than y or y greater than x, however you want to form it. And the compiler evaluates that expression depending on the results at that point in time. So this is always at runtime now, right? Because those values can change while the program is running and based on user input, etc. So at runtime, we're going to evaluate the expression, see how it evaluates. Does it evaluate the true or false? And depending on those results, you can see we'll branch one direction of our code or another. And eventually it all comes back together and will end at the same ending point. All right, and the last structure on the far right, that's what we're looking at today. It's called iteration. So iteration is to basically go over and over and over, repeat a process over and over and over. So that's what looping is all about. So in the case of iteration, you'll see there's also a true-false designation there. And so we are using expressions again, but this time it's evaluating true or false as to whether we should continue the looping process or not. So you'll see when we set up these structures, these iteration structures, that will identify a terminal value. So we'll say this is how long this loop can run through. Keep running these statements until this condition is met. So keep running this until x is equal to y, or something to that effect. So those are the 3 basic structures. And again, based on that theorem, the structured program theorem, theoretically then we can use one of those 3 structures in our program, or combinations of all of those 3 structures would be a better way to phrase that, and solve any problem, any computer problem that we need to. Terminology changes depending on who's talking about it and what languages we're using and the types of environments that we're in. But pretty much always when we're talking about iteration, you'll also hear them referred to as a repetition structure. So repetition, iteration basically mean the same thing. So you can see there we've got 4 of them we're going to look at here today. We've got the while loop, and then the do while loop, and then the for loop, and then the for each loop. So these repetition control structures can be used to execute the statements then that are internal to the loop, which we call the body of the looping structure, and it'll be dependent on some sort of loop termination criteria. As they say, we will set up some sort of an expression then that determines that termination point. The loop can also be terminated by using one of several control transfer statements. So we'll show you the break statement here a little bit later on, and the go to and the return or the throw. So all of those are just within the loop itself, aside from the expression that says here's when it should terminate. We can also set it up so that in certain cases internally in the loop there that we can break out of the loop, jump out of the loop, and return a value back to the caller of the loop many times. Let's go ahead and look at this introductory video here on the while loop.
So I'm going to write some simple iteration code here. But before I do, I have a quick question for you. And this is not a trick question. It's not a riddle, but I am interested in the first answer, your gut answer that comes to mind. Here's the question. You need to build a straight fence, and it must be 50 meters wide. And you need fence posts every 10 meters. How many fence posts do you need? Do you have your answer? Good. Let's get into the code. So in my JavaScript here, I'm going to create a simple while loop where I'll show you how to do it, and I'll show you one of the most common gotchas with iteration. I want to make a variable called amount. It starts off at 0, and I want to add the number 100 to it 10 times. So I'm going to create a loop to do that. So when I create a loop, as I mentioned, there's always 3 parts to it. So I'll add a few comments here just before we start to build it out. First, we're going to create the index. Then we're going to have the loop that checks the condition. And at some point, we need to have the ability to increment or add to the index. So these are just comments. Let's create an index here. It's very common to call your index I, but you can call it whatever you want. So we'll start off with an index of I equal to 1. Now I'm going to come and do my while loop. Again, takes the same format as ifs. We've got the word while, then our opening and closing parentheses, and then our opening and closing curly braces that represent the body of the loop. So in while, we've got the condition that we're going to check. Just like an if statement, this needs to be either true or false. And what I'm going to say is while I is less than 10, we're going to jump into the loop. And what I'm going to do is add 100 to amount, which I could say amount equals amount plus 100. I could have also used the plus equals format here. And then what I need to do inside the body of the loop is here's where I need to increment the index. I can't wait till I leave the loop, because if I do, we'll never hit that line. The increment must be inside the loop itself. I'm just going to say I++. So every time around, we're going to add 1 to the variable I. We'll then hit the end of the loop, the closing curly brace, and we'll jump back up to the while statement and check the condition again. Now finally, what I'm going to do is use our good old alert box and say the value is, and we'll write out the final value. We're only going to hit this line after we're done with the loop. And we write out the value of the variable called amount. So I'm going to save that and test it. So we're going through this. We're going to add 100 to amount 10 times, which should give us 1,000. But no, we get 900. This is a very common mistake to make. And some of you, I'm sure, have spotted the problem already. I started off with my index set to 1. And then I started the loop. Is I less than 10? Sure it is, it's 1. We then go through the loop, we add 1 to it, it's now 2. Is I less than 10? Sure it is, it's 2. We add another 100. We keep on going. Now at some point, I will go from 8 to 9, we'll loop around again, and then it will go from 9 to 10, and we'll loop around again. We'll check the condition. When I is 10, this will evaluate as false. So the last time we go around the loop was when I is equal to 9. So we're only actually adding 100 9 times, not 10 times. Now what could have worked here is either saying if I is less than or equal to 10, or we could have started off with our index set to 0, because that would have looped around once before we even incremented it to 1. But of course the flip side problem here is if I did both, and we try and save that and run that page again, we're now going to end up with 1100. So I want one solution or the other, but certainly not both. Now these are what is known as off by 1 errors. And it's really easy to go around either 1 too many times or 1 too few if you don't have it exactly straight in your head. And it's not computers causing this issue. The issue is with us. It's an easy mistake to make, even without computers involved. One example of this is known as the fence post error. This is the question that I asked earlier. You need to build a fence. It needs to be 50 meters wide, with fence posts every 10 meters. How many fence posts do you need? Now, a lot of people's gut reaction is 5. Some say 7. But the answer, of course, is 6. And if it's this easy to make off by 1 errors when we're working with really simple concepts like 50 divided by 10 or 100 times 10, how do you think it is when you're dealing with way more complex data with much more abstract start and end positions? And this is just one example. When we start working with collections of data, making sure that we're going through it exactly is quite easy to get wrong. Like with a fence post error, every programmer I've ever known will admit to making off by 1 errors. So a little extra thought with your loops can go a long way. The while loop is the classic loop in C-based languages. But after you've looked at a few, you'll realize that a pattern begins to emerge. That you always have to deal with the same elements. Regardless of what code you put in your loop, whether that's 1 line or 100 of them, you're dealing with setting up an index to keep track of the loop, and you have to do that outside of the loop itself. Then you're going to be checking the condition, and then you have to make sure that you're incrementing the index inside the loop, but at the end of it. So you always have these 3 pieces going on to have a successful loop. And this is such a common model. There's actually a statement that brings all these pieces together, and that's called a for loop.
So the off by 1 loop, as he pointed out, is a problematic situation that we have. You want to make sure that obviously the logic that you're putting into your program is going to be accurate so that we get the right results out. And so if you think about that particular situation, it's always going to be, when you needed to set up 5 posts, essentially, you always have to remember that you should, anyway, in most loops, there are exceptions to this, you should start at 0, as he kind of illustrated there. So that 0 means we always have a starting post, but from there we canning out 5 different posts. So it's always going to be basically 1 more than the count that you originally come up with as far as the spacing. So if you keep that in mind, that might help you with regards to your loops. So as we saw within the while loop there, you basically put in a statement, an expression that needs to be evaluated each time that we go through the loop. And so we've got an example here for you, which is kind of similar to what we saw there in the video. We're going to set up a program where we're going to have our, what he calls the index value there. You can call that the counter variable. It's also referred to as the, there is another name for it that escapes me for the moment. I usually just refer to it as the counter variable because that's the one that keeps track of how many times we're going through the loop. Then the expression is what we call the terminal value because that's what identifies when the loop should terminate. And then we just always, each time through the loop, we're going to have to increment it. So in a while loop, you can see that we do that within the actual while loop. When we get to some of the other structures, you'll see that all of these 3 elements, those are the 3 main elements, the index value, the terminal value, then and the incrementing of the counter variable there. So those 3 things have to happen in all these loops. And so you'll see that they move around a little bit just in positioning when we get to some of the other structures. So the while loop's been around for a long time, and it's one of the ones that's commonly used. I prefer, well, it kind of depends, I guess, what my goal is. If I'm going through a collection of items, I would recommend like a for loop or a for each loop, a little bit more practical, a little bit more efficient than is the while loop. And once we get down to those, I'll kind of explain more why I feel that way. But the while loop, I think, is probably one of the first looping structures that was created in the C-based languages. And so it's out there and it's used quite a bit. And you'll see that there's a companion to it as well called the do while loop. And that's coming up down here, down the road here in just a second. So for right now, let's go ahead and open up our Visual Studio. And we'll go ahead and put this code in there and test it out. Okay, so here we are on the start screen. Just going to go ahead and click on the Create New Project. Going to choose our console app, .NET Core, C#, and then we'll go ahead and click Next. So we'll call this one Repetition Structures. And let's see, for the first one, we want to call it the while loop. So That's right. I got this one always kind of throws me. I got to do this solution first. So repetition structures. And then up here, I want to put in while loop. So again, we're going to have multiple projects in here, and I just want to distinguish between each project with the project name, but make them all part of one solution. So project name is while loop, solution name, repetition structures. Click on create. Then I want to just copy the code here that I have for you in the lesson. Let's get it all, including the spacing there. Don't want the image. So let's move Video Studio back into place here, Visual Studio, and paste it in there. Okay, so we've got the standard using directive of using system there. Our namespace is the name of our project, which is the while statement. Inside of our class program, we've got our main, and then here we have the creation of the index value. So we're creating an integer of type I, and it's going to be called I, assign a value 1 to it. And so now we use I inside of the expression for our while loop. This says that we're going to run this as long as I is less than or equal to 5. So how many times is it going to run? What would you guess? Or what, let's just go a little further here. You can see that we're going to output the value of I each time we go through the loop. What's going to be the final value of I? No guesses? Nobody's brave enough to speak up? Elizabeth?
I don't know. It's either 5 or 6. I don't know if it goes past the number or.
Well, no, see, this is going to be equal to, right? Yeah. So while it's lesser than or equal to, we're going to start at 1.
5.
Yeah.
So 5 should be 5 should be correct, right? So let's make sure of that. Just one more point here is that we're incrementing that index value each time we're going through the loop. And again, in a while loop, notice that's done internally within the loop after all the statements have run. Okay, so let's go ahead and run this then. Control F5. And then here's the output. So we have first time through the loop, the value of I is 1. The second time through the loop, it's 2, then 3, and then 4, and then 5. So you are correct. So what happens then if we change this to a 0? So now we're starting at the 0 value, and this is, when I was talking about arrays, I always emphasize that it's a 0-based data type, because one of the most common problems is that new programmers don't understand that when you're looking at the first value in the array, that it's really the 0 element. And so while loops work really good this way, but we got to remember that we want to, if we're going to show values from an array, we always want to start at 0. Otherwise, if we start at 1, we actually are looking at the second element in the array each time, and then going forward from there, we're not actually getting the first one. So it's important to, know your data structures as well as how these loops work. So in the case of an array, and really, I'm thinking most of the situations that I do, primarily my index value seems to me it always starts at 0. And certainly, again, there are exceptions for that, but just it's a very common thing to have that index value start at 0. So in this case, hopefully you can figure the math out on that one, since we are starting one number prior to 1. Then
it still ends at 5.
It still ends at 5, do you think?
That's my guess.
Okay. Well, in this particular case, that would be correct. The end result of I is still going to be 5, but
in an array, it would be 6.
Well, don't even think of it as an array right now, but just think how many actual lines of output then will there be?
6, because of the 0, right?
Right, because we are going to have 0 as the first value, right? So
yeah, 6. That's why I said it was to be 6 if it was an array.
No, but that's what I'm saying. It doesn't have to be an array here. We're not dealing with an array. This is the reason we're getting 6 outputs is because of the way that the index value and the expression that evaluates, when to terminate. That's what's dictating that we'll get 6 lines. This has nothing to do with an array at this point. Okay?
Oh, okay.
Well, let's go ahead and save that and run it. Control F5. Bring this on over, and there you can see, since we started at 0, we do end up with 6 total values being output, but we are just still incrementing up into the value of 5. But the difference is how many outputs were generated. We got 6 this time instead of 5. If we wanted to do this using an array, okay, so now we've got the array. Now we got the starting index value. We're going to go to less than or equal 5. This should throw an error because we only have 5 elements. So that's what I want to demonstrate here. So this is element 0, right? This value 1 is element 0. And then the value 2 is element 1, element 2, element 3, element 4. But we're saying go to, loop through here until you hit 5. So that should throw an error for us. This shows that one-off error. And let's just see what we're doing on the output here. We're just showing the value of I at that point in time. And then incrementing I. So that should work. So let's go ahead and run this. It actually didn't throw. Oh, no, that's not right. Here now, we want to show the value of the array, not I. We're not using the counter variable anymore. See, this actually requires more thought than you would think. So console.writeLine will actually be my array at the current value of I. So what we're saying now is when we go to do the output, go into the my array variable, look for whatever I's value is, that's going to represent the element number that we're targeting. And so the first time through, when we have 0, it should show the 1, then it'll show the 2, then the 3, and the 4, and the 5. But then it's going to go through the loop one more time because the index right here is only 4, right? So it'll go through one more time, and that's where we should see the error, which is what I'm trying to demonstrate here. Yeah, there we go. Okay, so there's the first 5 values, or all the values, right, in the array, 1, 2, 3, 4, 5. But then right here, you can see we get this unhandled exception error. And it tells us that the index was outside the bounds, meaning the length of the array. So that's why, generally speaking, this is what I was mentioning earlier, that I always have the lesser than symbol there in my expression, because equals to mathematically takes it one too far. And just from my own brain, the way that I think about things, I know that I have a 5-element array up here, so it's just a lot easier for me then to put in that value, but make it lesser than, right? Don't ever make it lesser than equal to. Now, there is a way to solve that. One of the nice things about the array is it has a length property. So the length property is always going to be the number of elements in the array. So if we type in, instead of a numeric value there in the expression, if we do I less than my array, and then its length property, that's the same thing as typing in the number 5 there, because the compiler looks at that array and says, oh, there are 5 elements in that array. So the key is we need to A, start the counter variable at 0, and then B, in the expression, just make sure we're always using the less than operator when we're targeting the array and trying to determine how many times to go through the loop. If we just use the lesser than operator, we'll always have the right number there, because length is always going to be the exact number of elements in the array. Does that make sense?
Yeah.
Okay, go back to the lecture here. In the example I'm showing you here now, I've actually added a custom method to it. So the code that we used here looks like I updated this graphic at a later date because for some reason I added a method in here. So this is just showing you that you can, from your static main, you can actually call what we call a method, which is an organized group of blocks of code that we refer to by its name. It's just anytime we want to run this block of code, we just use the name of that block of code, which is right here defined as while test. And that's really not coming up until we get to lesson 10, I think it is, when we start talking about modular programming. But as far as the while loop and how it's working, it's all pretty much what we're just looking at there. In fact, this is the same structure. I just ended up putting it in a custom method is all, which when you get to 10, you'll understand that's kind of a common thing to do too. If you've got things that you want to run, you know, blocks of code you want to run over and over again, you can, and this is a little different. I should not confuse the issue that we're talking about repetition structures either. Because a repetition structure is just simply saying, let's take this block of code and run it over for a certain number of times. A method is whenever it's called in the program, we want to run that block of code and then come back to that line in the program. So if I wanted to do this a couple of times, I could put while test parentheses semicolon. I could list that up here a couple of times. So that's a little bit different than, it's quite a bit different actually than repetition structures. Repetition structures always have that terminal value. You know, this while loop is the repetition structure. So what we're really doing is creating a method that will call that particular repetition structure at will. You know, anywhere in our program that we list that line of code, it'll run this block down here, which is our repetition structure. Another term to here that we have for the index value is initializer. And then termination expression. I've never really liked that because really this is just incrementing the value until you reach the terminal value that's set up here in the while loop. One of the big problems we have with while loops is creating a never-ending loop. So like just going back to our previous code here. Actually, let's go back. It'd be easier if I just copy it from here. I might just go back to the original one because the original one is a better way of showing it. Okay, so you might recall in the video, for instance, the narrator there was talking about the fact that that incrementation of our counter variable needs to be inside the while loop. Otherwise, it's just going to run forever. So I'm going to move that outside to demonstrate that for you. So we'll go ahead and save that. Go ahead and run it. Control F5. And here you can see it's not able to increment the value. If you look closely at my cursor here, it's flashing because it's still displaying to the screen at this very moment. So the way to stop that is hold down Control and press the C on the keyboard. At least on a PC, it's Control C to escape from an unending loop there. So if I scroll up, you'll see that it just goes on and on and on. Here, I'll drag my cursor up, or my scroll bar up. You can see the value's not changing either, right? It's always 1 because it never incremented inside of the loop. So it just kept going round and 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 round until I did the Control C to stop it. So that is a big problem. That's just one reason why you don't have the incrementation correct. You might also have an expression up here that will never end. You know, if I had do this as well, y, well, I is say greater than 0. Okay, so I is 1 to start with, so it is greater than 0, and it'll increment now internally all the way through. It'll keep going up, but there's no way that it's going to stop because I will never be anything but greater than 0. So let's go ahead and save that and run it. And there you can see very quickly I got into the thousands. It just gives you an idea how fast your computer actually processes numeric values. and on and on and on until we do the Control C again. Go ahead.
It was at the 10,000s now.
Yeah, very quickly, huh? So that's, one of the common problems that we run into, setting up expressions that will not terminate, not having the incrementation of the counter variable in the right position. Just a few examples of, where you might run into trouble. In this next example here, just showing you a flowchart equivalent of the program that we had written up above. So remember we talked about diagramming out our programs early on. That was, I think, lesson 3. And so it's good to take a look at that and see how you would write out a while loop. It's very similar to an if statement because you're always evaluating. You've got an expression that needs to be evaluated. Just the difference is that it loops. Instead of branching, it loops. So the while loop, just to remind you again, the terminal expression is in the parentheses just after the keyword while there. So we're moving on now to the do while loop. And the way that a do while loop works is that we use the keyword do, and then in the curly braces, we'll have the statement blocks that we want to run. And then after all those statement blocks run within that loop then, or at the very end of that loop, the do loop, then the while kicks in with the expression as to whether or not it should continue. So the main difference then between that first one, the while loop that I showed you up above, and this one, the do while loop, is that it will always, the do while loop will always run these groups of statements before it actually tests the expression. Whereas in the while loop, the expression was tested immediately to see if we should even begin to run the loop at all. So there is kind of an example out there that's been used quite a bit to demonstrate where you would consider using a while loop versus a do loop. And it's in preparing a pot of stew or a pot of soup. If you want to test as you're cooking your soup up, you want to test and see if it needs some salt in there, you've got two choices. You could just add the salt and then taste it to see if it's too salty. And if it's too salty, don't add any more. So that would be like a do loop because we did the task first. We added the salt and then we tested it. A while loop would be you would actually first test the soup to see if it's too salty or not, and then determine whether or not you needed to add the salt in there. Do you see the difference? Does that make sense? All right, so a do loop, we're throwing salt in there without ever testing it. In the while loop, we always test first. So here's our example down below then of the do while loop. Bring our Visual Studio back up here. So now what I want to do is I'm going to go up to my solution here. I'm going to right click on my solution, add a new project. And the new project will be my do whiles loop. Okay, so we got our using directive, we got the namespace, the program inside the main now. We've initialized an I variable as an int, assign a value of 1 to it. So what we should see, because we're doing a do while now, is that this line of code here is going to be written to the screen immediately. Then it's going to increment I, then it's going to test to see whether or not it should continue or not. And we're using the less than or equal to 5 on this one. So what do you think the output of this is going to look like? Should look very similar to what we saw a moment ago, because basically the way it's set up, it should generate. And I do want to remember to switch over here to startup project to make sure that's what's running. Okay, there we go. So it should just generate, just like we saw in the first example, the same results, 1, 2, 3, 4, 5. The difference though is, let's make I equal to 6 here, which we know is not less than or equal to 5. And now let's go ahead and run that. And there you can see it did indeed output the value I is 6. So it did run this line of code here before it came down and actually did the evaluation. And we could have made that 5 as well. We could make that any number actually, but I'm just thinking that with 5, it would run and then it would increment 5 to 6 and then it would fail. But it's always going to print this at least once. That's the whole thing about a do. We're going to do it first, then we're going to check it. So hopefully you see the difference there then between the two, the while loop and the do while loop. Yeah, here's the analogy that I just was telling you about. I did put that into the lesson there, but that's a good way to remember when you want to use a do loop versus a while loop. Moving on to our next looping structure, which is the for loop. So the nice thing about the for loop is that it combines those 3 elements that we need for looping all in one expression or one line of code. So you can see we use the keyword for, and in the parentheses, we'll initialize the counter variable, we'll set the conditions, and then we'll also increment the counter variable or decrement, depending on which direction you want to go. You can, the examples I've used so far is we've been counting upwards, but you could also count backwards if you needed to. Then you just basically create a set of curly braces and you put your statement blocks then that you want to have looped inside of the curly braces. So here's our example down here for the for loop. Let's go ahead and pop this into our Visual Studio. So create a new project for this one. That's going to be the for loop. Oops, that's right. For this new interface, you have to select the template. Then we put in the name. There we go. Okay, so I'll paste in the code there for the for loop. So again, you can see that we're setting up our counting variable here. It's going to be of int type. I'm going to call it I. And I, by the way, is a very common value to use or name to use for that particular value because it's, commonly referred to as the index, where we're at in the loop. It identifies, how many times through the loop or where we're at in the loop. So they call that the index. So pretty much all examples you'll ever see probably with for loops will always have int I. Now, there are some problems with that. For instance, if I was going to have more than one for loop, then if I've already established the variable I wouldn't want to have that conflict with another variable I within the same program. And so you would actually, a lot of folks, if they're going to have 2 for loops, the first one will have the counter variable be I, and the second will be like J. You could keep incrementing from there, J, K, L. So, you don't want to have, you can never create 2 variables of the same name. Obviously, that would be in conflict, would create a problem. So our counter variable is initialized with a value, and then here is the conditional expression. And notice how in the for loop, what we're doing is we're setting up, or separating, I should say, each of these components with a semicolon. So we initialize the counter variable, semicolon. We put in the termination expression, semicolon. And then we put in the incrementation of the counter variable each time through the loop. And as I said, we could actually go backwards. We could decrement here. So if we didn't use the plus plus operator, we could use the minus minus operator. So it just depends on whether you need to be counting up or counting down. And then in this example, we're just writing one statement here, which is, again, just the value of I at that current position using the older composite formatting format there. So we'll go ahead and save that, run it. So pretty much the same output, but just using a different looping structure. In this particular case, we really didn't have any restricted parameters. In other words, we weren't parsing through an array where we had to have a known terminal value there. So we could have changed this to just any number. That would just determine how many outputs we're going to get in that loop there. For loops, just from my own personal experience, I can tell you, pretty commonly used when you're going to go through your arrays, parsing or evaluating, looking at each individual element one at a time. But again, if you're going to use arrays, you pretty much always want to start your counter variable at 0 because that's always the first index value in the array. So in this case here, all I've done is just change it. So now we would get 6 outputs, right? Just like we showed you in the previous example with the while loop. This would start at 0, end at 5, but 6 total outputs would be generated. Yeah, just showing you that this is like the very minimal that you would write out to create a for loop that doesn't do anything at all, but they're just showing you that that is possible. So in the example that we have down here now, we're going to use both a while loop and a for loop. So this is the one I was actually looking for earlier. This one here, this while loop is going to populate our array. So you can see here, we've established the fact that we want to declare an array of type string. It's going to be called my array, and it'll have 10 slots in it to begin with. And just, I think I mentioned this to you the other day, but when we, if we just declare the array and give it a certain number of elements, but we don't actually put values in there, just remember that those values are all 0 to start with. So we start out with an array. It's going to have 10 slots in it, 10 elements, and it's going to be called my array. And then since we're using a while loop here, we want to set up our counter variable. So we created an integer called counter, set it at 0. Then here's the while loop, and the expression is as long as our counter variable is less than the length of our array. So again, reiterating, parsing arrays, our counter variable starts at 0, and we want to use the less than operator when we're comparing it in the expression. And all we have to do then is use the length property, and that always gives us however many elements are in that particular array. Then internally here, we're doing an output statement where we're actually going to take a number then from the user. So the user can randomly enter numbers. And whatever the value is then that the user types in, that's going to be assigned to the current element. As we're going through the loop here, remember that this value counter is going to change from 0 to 1 to 2 to 3, on and on up to 10. So that's just going to keep going. And so it's all each element, each time we are at an element in the loop, we're going to just take the user's input and assign it into that position in the array. And then here we're just incrementing the counter variable so that now when it loops back around, now we go from 0 to 1 or 1 to 2. That's just populating the array. Then here we're using the sort method on our array. So there is an array object, and it has a sort method. And the way that it works is inside of the parentheses, we list the name of our array that we just created up here. Right, this was the string my array that we created up here and then populated it here. So now what we're doing is taking those randomly input values from our user, and we're going to sort them. Well, this is the code that we do it with. So let's go ahead now, and I'm going to copy all of this. And all of this needs to be put inside of a main method. Can I get that space? There it is. So we'll copy all that. Let's come back, create a new project here.
Are we going to name it while for loop?
I was just going to do like while for example, I think. You can call it whatever you want, as long as you can find it later on, right? So really what you call it doesn't matter as long as you know what the heck that name is representing as far as the code that you've written. So I was just thinking like while dash for example. And then I'll create it. Come inside of the main, because the code that we have there, the example code, if you look at it, it's not a complete program, right? This is just the code that goes inside of the main. In fact, I made a note of it here for you. Place the code inside of the main method. So I don't want you to think that's an entire program. actually had somebody in the online class submitting just blocks of code as if they were entire programs, and have to explain that you can't run those blocks of code unless you put it into the full structure of a program. You have to have the system directive and the namespace and the class and the main method, because otherwise the compiler has no idea what to do. Okay, so we've gone over the code, so let's just go ahead and run it now. Control F5. Okay, so here we're just typing in numbers just at random. So in this particular case, looks like we pretty much got everything sorted in the right order there, just because of the sequence that I typed in. Well, no, I guess we didn't. I was only looking at the first digit. But I'm pretty sure that 4 and 5 should become before 148 and 346. Would you agree? And probably 76
Yes.
and 97 and 98 should come before 148 and 346.
Yes.
So obviously that is not sorted in order. This is what we were talking about the other day, because we're using strings here. And then the way to convert that is to make this an integer array. And the problem that creates, as we can see, we get the red squiggly under console.readline, because the IntelliSense that's running behind the scenes here as we write our code, it's recognizing the fact that, hey, you're going to be getting input from here, and this is only string input. You're going to try to assign it into an array that only accepts integers. That ain't going to work. And so the other day, I can remember that I showed you this. We just used the convert, and we convert it to an
Int 23.
I
No,
got it
32,
backwards.
sorry.
32, yeah. So you have to think in bits. It's 16-bit, 32-bit, 64-bit.
I actually did it backwards on accident.
That's good. You made a try. That's good. So an int 32, and then that's the int 32 is an actual method. So that means that it has parentheses that we need to pass information into it for the processing. So what we're passing into the int 32 method is the input from the user. That'll take the string value, convert it to an integer 32, and now we can legally assign that value into our array here. Then does that affect our output at all? Not at all, but what we could do here is, just because I'm tired of looking at this old composite formatting, let's do it the correct way. So this is I, and this is my array at I value. And we just get rid of all that now. It just makes it so much simpler, so much cleaner. The old way works, but it's just not as clean as this way here. And I make sure I got everything packed. Yeah, so open curly, close curly, open, close, open, close. That should be all formatted correctly. So let's go ahead and run it. So just like we did before, random numbers. Just letting my fingers do the walking on my numeric keypad here. Looks like it keeps being up there at the 9. And that won't work. There we go. So now we can see everything is numerically sorted correctly because we're using integers instead of strings. And we don't have quizzes in this class, but if there was a question on a quiz that asked you what the data type is when a user types a value from the keyboard, the answer would be what? What's the data type of the value that comes in when the user types on the keyboard? Really? I haven't made that clear enough? So it's a string type, always. So you always have to take the input from the user, know that it's string, and the reason you need to know it's string is for what I demonstrated here. You'll need to know when you need to convert it to make your program work. So if you need numeric values, right, if you're going to do mathematical operations based on user input, then you definitely would need to convert that to integers or doubles or floats or some sort of a numeric data type. So that's very important that you keep that in mind. Now, so that was a for loop that we were focusing on. And in the last example, I combined the while with the for. So the while, I used that just to demonstrate how you can take the input from the keyboard, assign it into the array, and then we sorted the array, and then we used the for loop to see what the current values were in the order of each of the elements within the array. A for each loop is really cool because you don't have to put in all of the values that we normally have for our loops. So we don't have to have the index value, we don't have to have the expression, and we don't have to do the incrementing. Because the way that a for each loop works is that it will actually know the length of the collection. In fact, I should point out that that's generally what we use the for each loop for, is whenever we're dealing with collections of values, iterating through a collection of values. So the way that the for each works is, if you look down here, right here is the actual for each statement. So the way that this one works is that we just declared an array of integers here. We're calling the array numbers. And so the for each loop then actually just declares a variable here so that we can use it internally within the loop. So what the I represents at this point is whatever the actual value is in this numbers array. So you see the way that it reads is, what we're looking for is, give me the current value of I in numbers. So the for each loop knows how many elements are there, so it'll loop through the proper number of times. So we don't have to have a counter variable, we don't have to have an increment variable. Basically, we just have to have one variable that identifies some variable name that we can use here internally to actually display what the value is that's being pulled in from the array here. So let's go ahead and put this in as a new project in our Visual Studio. So new project. Again, C#, .NET Core, console app. And this one we'll call for each loop. Okay, so again, establishing a new array called numbers. It'll have 5 digits in it in that order, and then just using a for each loop to iterate through and display each of the values, again using this variable that was established right here, I, of type integer. So it's just saying that's the type that we are expecting to grab here from the array called numbers. And we are introducing you in the for each to a new keyword here too, the in keyword. So you see that primarily used in the for each loops. So let's save that. Let's make sure that our for each loop is our startup project. Now we can go ahead and run this. And the output, again, just the same as we've seen before, just a different way of doing it. For each loop is perfect for arrays. It's great for iterating through the arrays. The drawback that you might have here is that you can't quite do as much with the values that you're pulling in, because we don't have really a counter variable that we can use to target the specific element. The array is, the for each is just going to go through the entire array and just grab each value and just display it out here. So I can't manipulate it quite as well as when I use a for loop, because a for loop I can actually target the individual element and do more things with it. So there are some limitations with the for each, but just quickly going through and grabbing the values and displaying them, you can see that's the shortest block of code we've written so far today, right? And it's still giving us the same output. So anytime you have an array and you just want to grab the outputs, that's the simplest thing to use, the for each. Then the next thing we look at is a concept called recursion. So up until this point, we didn't have any methods that were created. And so the way that the recursion works is that you create blocks of code that, again, are going to be iterated through, but a little bit differently now. And the best way to explain it is I need to show you the code down here. So we set up initially inside of our main, all we have there is one statement. And what that statement is doing is it's calling this function, well, actually a method, we're in a object oriented, so it's method here, called factorial. And it's passing into it a value of 5. In the previous loops, we would then, run that for a certain amount of times to generate the output, but we weren't having to recall the loop. It's like once we're in the loop, we stay in the loop. The difference between looping and recursion is that you always create a method, or it could be a function. And what's happening is within the function or method itself, you're actually calling that method or function within the actual method or function. That's what is recursion. The fact that you create a function of a certain name and then internally within that function, you actually call itself. That's the best way the simplest way I can explain how recursion works. So in this example, what we're doing is we're actually trying to solve this problem up here, which is a factorial problem. I don't know if you've ever been in a math statistics class, but usually that's where they teach you factorial. So factorial is actually an operator, the exclamation point here. So the way that a factorial works is you write out a number, follow it by an exclamation point, and that then is in itself a formula that's called a factorial. And the actual mathematic that occurs then is that we take whatever value is typed in there. So in this example, we can say that we typed in the number 3. So whatever the number is that's n here, followed by the exclamation point, which is just the factorial operator, what that's really saying is take that value, multiply it times the value minus 1. So in this case, 3 times 2. That's going to give us 6. Then, actually, this doesn't look to be written out correctly when I look at it. Yeah, this actually has factorials inside of it. Oh, so this is showing what the recursion is actually doing. So to explain factorial, just realize it's 3 times 2 times 1. If the number here is 3, you're going to multiply it times the numbers that are lesser than it. If the number was 4, I'd multiply times 4 times 3 times 2 times 1. If the number was 5, I'd multiply 5 times 4 times 3 times 2 times 1. So it's always all the numbers that are lesser than you're multiplying that original number by. That's how a factorial works. So for instance, 5, the factorial, I think if I recall correctly, is 120. So the way that the program then is going to be written is, like I said, using this concept of recursion, because you're always going to do this same formula here, which is the number that was given. So in this example, we're using 5. So it's going to be the number that was given minus 1 times the number that was given. So I should have read it the other way to you. The number that was given times, and here we're just calling our function again. But now that when we're calling the function, we're actually subtracting 1 from the original value. So that's what they call the recursive case. So what that should do then is give us the value of 5 times 4. Then it calls itself again and does 4 times 3, and then it calls itself again, does 3 times 2, and then calls itself again 2 times 1. And actually it terminates, once you get to 1, then there is really no more recursion occurring there. So we'll go ahead and put this into a program, show you how it runs. Just thinking we could probably even do a debug on this and see the values as it go. Might help you see it a little bit better. So we'll add in new project, C#.NET Core, call this one recursion. And the code that I had was where from the main space, the namespace. So I just want to go from there to there. Save it and make it the startup project. Okay, so initially I'll just go ahead and run it for you. Uh-oh, we got build errors. Oh, I got an extra curly there. All right, run it again. It's still actually throwing an error. What's going on? Oh, I'm not doing any output here. Okay, let's do this. So we're returning. What we want to do is just put a console.writeLine and output then the results of our program. So actually our call to the function. So we really want to just take this value and put it in the parentheses there. So this is actually a really cool demonstration because what we're showing you is that if we put a function inside of our WriteLine method, what happens is the function runs, and whatever the results then of running that function are, that's the value then that will be output here from our console WriteLine. And why can't I get that right? There we are. So console WriteLine, calling the factorial method here and passing in the value of 5 to it. And that's a statement. That's why I'm getting the red squiggly right there. So that should work. All right. Now we'll run it. Now we should see the output. There we go. So you can see the factorial of 5 is indeed 120. You can do the math on that yourself. 5 times 4 times 3 times 2, and you should get 120. So let's just put a different value in there now. Of course, we could set up this program where we take input from the user as well if you're interested in doing that. Let's just say 4 this time. So I'll save that, run it. So now it's 4 times 3 times 2. That's an easy one to figure out, right? 24. So now you know that if you ever have a statistical math course, you can write a program that will solve anything that they throw at you as far as factorials are concerned. Although it's not really that difficult a math process. Let's see if I can't demonstrate here the debugging process like we did the other day. We should be able to actually see the values here as we increment. So let's save that. Let's go ahead and run it now in debug mode. Okay, so I have no values showing in my console at the moment. Just what we see though here in our locals is that we have our value n. So remember that n is what we're using as the variable here, right? So n is equal to 4. Now we'll go ahead and step into it. Now there's the if statement, just checking to see that it's not 0. So there, since it's skipped, so it showed you that, you know, this expression here evaluated to false. So it's skipped down here now to the else, where it's going to run this line of code here. So we'll step into that. Now you can see that we're getting the value 3 passed in because we did the n minus 1. And then we're looping back around again. Again, it's not 0. So now we're going to get the value 2 in there. And the 1. And then the next time around, it'll be 0. So this time it just returns a 1, the base case, and then 0. Of course, we don't multiply by 0. So one more time through, then it exits. There's the incrementation. Yeah, there we go. So it actually grabbed all the values first, and then it had to run through the math, which was to take each of those values, multiply them times each other, and then we got the 24. And then that should end it at that point. So anytime you want to look at code, remember, you can always throw those breakpoints in there, and just when you go to run it, make sure you run it with just F5 or just by choosing this option, start debugging, instead of the without debugging. That's what you normally are doing, is without the debugging. So you do want to debug it if you want to see the results in the locals. All right, moving on from there. Just some different recursion examples here. In this one, we are actually taking input from the user. So we can go ahead and copy this and just give you a quick demo on it.
Can we name it recursions too?
Yeah, again, the naming doesn't really matter, but I was thinking maybe recursion with user input. Just a little clearer as to, you know, what it's going to do for us. It's going to do a recursive problem based on user input. Okay, so select all that, place it. So here we just got a prompt for the user to enter the number. That'll be the number then that is used or assigned to our number integer variable. And then here's the console.writeLine statement where we're taking the value of number, or yeah, the current value of number there, and saying that it is, and then outputting this here, what the actual results are, right, which is the actual factorial operation completed. See, we've changed the name of our method now to compute factorial. So that's the method right here that we're being called right here. And we're passing the value of number, which is going to be 3, 4, 5. You don't want to get too high on these. If I forget what number it is where that just gets beyond the capability of a 32-bit integer. 4 million and something. No, 4 billion and something, right? Yeah. 2 to the 32nd is a little over 4 billion. So anyway, if you have a factorial that exceeds that value, then it won't be able to process it. And the factorial internally, no difference here. Just again, starting with the original factorial at 1, and then going through and incrementing the number or decrementing the number each time through. So it actually is a little bit different formula than what we saw before. Yeah, this one's not using recursive. That's the main difference that we're seeing here. I was trying to figure out why I did it that way. Similar to, but different than what we saw before. You know, this is where we subtracted the number in the last one. I'm just using the decrement operator instead of the formula n-1. Okay, so let's make that now our startup project. We'll go ahead and run it. And so let's, we know 5 is going to be 120, so let's put 5 in there. See that we do get the correct output. The factorial of 5 is 120. Let's go ahead and run it again. Let's see if we can break it here. I think if I put the number of 20 or 12 in there, it might freak. No, not quite big enough. What is that? That's thousands, so we're only in the millions at that point.
I did 22 and it's a negative number.
22? Okay, let's do that. So yeah, so when you start seeing negative values in there, that's because we've exceeded the capacity of what a 32-bit integer can hold in memory.
Aren't we not limited by 32-bit anymore because most operating systems are leaning towards 64-bit nowadays?
Oh, absolutely. No, I'm using a 64-bit operating system. No, that's not the question or the problem. Here's the problem right there. right? We've defined in our code that we want to convert it to a 32-bit integer. So that's dictating the data type. So that's telling the compiler, you cannot exceed the number of bits that supports a 32-bit integer.
Okay, thank you.